Kim Shepard again, back with video 9D. The main idea in this video is looking at the formulas for the slope and the y-intercept of your regression equation. And so we're back to the direct loan problem. Recall here's a snapshot of what the data looks like. So we've got each school, the number of loans, which was X, and the loan value, which was Y. You'll also see in your notes that you have some summary information from that data set. There were 63 schools that we had data on, and we have the mean value for both of our variables as well as the standard deviation. Remember that number of loans was X, loan value was Y. So you can think about this as the average X value. This is the average Y value. And over here we have standard deviations. The symbol for this was based on a sample. The symbol for sample standard deviation is S. And to denote that this one goes with the number of loans, goes with the X variable, I'm going to give it a little subscript of X. And to denote that this is the standard deviation for the Y variable, I'm going to tack on there a little subscript of Y. And then some other output from StatCrunch. We know that the correlation between our two variables is roughly 0.98. Remember, this is R, the correlation coefficient. And then finally, you also have the regression equation. And one adjustment, we'll stick a hat on that to remind ourselves that that's the predicted loan value. And we see the value of the slope and the value of the y-intercept. Okay, so the point of this video is to talk about where'd that value of the slope come from? And where'd the value of the y-intercept come from? Could we compute the value of the slope and the y-intercept? And we can, and so I want to talk about the formulas and where they come from. Okay, so there are formulas to compute the slope and the y-intercept. Many times we won't have to use them. If we have data loaded in StatCrunch, for the most part, StatCrunch is going to give us the equation of that regression line. But they're interesting in their own right and good to know, what StatCrunch is doing when they compute those. The formulas are based on three of the most important summary statistics that we know. They're based on the mean, the standard deviation, and the correlation. So all things that we were previously sort of summarized there at the top of this problem for us. So we'll see how these three important summary statistics, how we use those in the formulas for slope and y-intercept. Okay, so what are the formulas for the slope and the y-intercept? Let's start with the slope. The slope is the correlation coefficient R, and then we multiply by the standard deviation for Y divided by the standard deviation for X. And some of this kind of makes some sense here. The correlation coefficient, if your relationship is positive, as X increases, Y increases, that correlation coefficient is going to be positive. That will mean that your slope is positive as well. Recall that standard deviations can never be negative. So these are, the smallest they could possibly be would be 0. That'd be really unusual. But if this is a positive number, if the correlation's positive, your slope's going to be positive. If the correlation's negative, your line goes the other way, the slope of your line is going to be negative. You also recall from algebra, slope is like rise over run, change in y over change in x. So, we sort of see the change in y and the change in x incorporated there with that standard deviation. Just to recall here, R is your correlation coefficient. You should know that. And S with the y on it is the standard deviation for the y variable. And when we put a subscript of x, that's the standard deviation for x. And all right, so how about for the direct loan problem? Let's go ahead and compute this. You have it right there in your notes that the correlation coefficient, I'm going to round, was roughly 0.984. And you also have right there in your notes that the standard deviation for the y variable was 6,704,153. standard deviation for x was 2,787.52. This one was a money figure here. And when you compute this all out, we get that the slope is roughly $2,366.58. I think StatCrunch gave it to us as 2,366. We are rounding some values. This is rounded. These may even be rounded, I'm not sure. But we get a value pretty close to what StatCrunch gives us there. So that's the formula that's being used to compute the slope of a regression line. All right, how about the value of the y-intercept? Where's that come from? So the formula for the y-intercept is based on the fact that every linear regression equation is guaranteed to go through the point, the average y, the average x. So if you know what the average x value is, the average y value is, that's going to be a point on your regression line. So you could look back at your summary information on the previous page. The average number of loans was like 2,308.56, and the average loan value was almost 5 million. That's going to be a point on the line. Okay, so we're going to use that fact to figure out the formula here for the slope. So if we think about our regression equation, general form of our regression equation looks like this. And now I'm going to use the fact that this is a point on the line. So I'm going to plug that ordered pair into the line. So let's plug in the point average x, average y. And when we do that, this becomes the average y. This is the average x. And we have this equation. If you take this equation and solve for the y-intercept, that's the formula for the y-intercept. So we'll just do some algebra, solve for b sub 0. You ought to be able to do algebra and solve that for b sub 0. If you can't, you need to come see your instructor during office hours, because that's a prerequisite for this class. So, and some of you might not be able to do that, so please come see us. We want to make sure that you know how to do that. But if you solve this for b sub 0, oops, don't forget my average value there, we get this equation for the y-intercept. So the formula for the y-intercept, here it is. The y-intercept is the average y value minus the slope times the average x value. All right, so let's wrap this up, go back to the direct loan problem, and use our formula to compute the y-intercept. All right, so here was my formula. If we plug in the average y value, was the slope that we just computed, you'll notice that the y-intercept formula, you need the slope. So you have to do the slope first if you're going to be finding these with formulas. We found that that was 2,366.58. And then the average x value was 2,308.56. And if you work that out, compute this, we get a y-intercept value here of negative 475,427.93. I think the value that we had from StatCrunch was negative 474,958. They're off by quite a bit there. That's due to rounding. We have several things that we rounded. The correlation coefficient was rounded, and so that affected the value of the slope. Some of those averages and standard deviations, that I'm not sure about. I'd have to go back and check the data. But the difference there is due to rounding. So you know, a bit of a difference here due to rounding. But in general, this is how the y-intercept of a regression line is found. So those are the formulas. We'll use them in a few problems to figure out what the slope and the y-intercept of a problem are. And then in many others, we'll go ahead and use StatCrunch and let them come up with the equation for us. But it's important to know where they come from. So that's it for this one.